Today we're going to talk about inverse functions. So to start off with, I just want to talk about some features of functions and their inverse functions, and then we'll get into how to find an inverse function. At the end of today's lesson, you should be able to find the inverse function for this number 1, for the function 5x minus 2, and we'll get into how to do that here in a minute. And then secondly, you should be able to explain how to find the inverse function in your own words. Why are we learning about inverse functions? Well, those can be used for encoding and then decoding messages, or encrypting and then decrypting messages. They can be thought of as driving directions to get someplace, and then the reverse driving directions would be the inverse function of that. And you're actually experienced with inverse functions, although nobody's said that to you before, but every time you solve an equation for x, you're actually performing all of the steps of an inverse function in order to get x. So let's talk about inverse and what that usually means with respect to operation. So operations have inverse operations, and inverse just means basically the opposite thing. So addition and subtraction, multiplication and division, those are examples of operations that are inverses from each other. For instance, a square and a square root. So basically a function and an inverse function have a similar relationship. A function does a series of steps to x, and the inverse function does those opposite operations in reverse order to that variable. So to give you an example, on the left I have a function, and then on the right hand side there's the inverse function. And we just want to think about the order of operations if we were going to evaluate these functions. So take a second, and I want you to list all the steps in that first left-hand function. What would you do if I was substituting in a number for x? What are the things that you would do to it? So you should have said that first you would multiply by 2, and then you would add 1, and that's just following the order of operations. Now let's look at that second function. Now the superscript that's here with that little -1, that is not a power, so I don't want you to think that that's a power, but that's actually just notation that means inverse function. So when you put that superscript there on the f to indicate the function, you're telling your reader, hey, this is the inverse function of that other function f. So I want you to take a second and think about if you were substituting in a number for x, what was the order that you would do things in as far as mathematically performing those operations? So you should have said that first you would subtract 1 and then you would divide by 2. So if we just look at these and kind of compare them, what do we notice about these two functions? So you should have noticed that they perform the inverse operations, or the opposite operations, and they are in inverse order, so the reverse order of each other. Let's compare a second example. On the left we have the function, and on the right we have the inverse function. Again, that little -1 superscript indicates to the reader that that is the inverse function of f. So perform the same task. I want you to list out the order of operations for that first function, and then list out the order of operations for that second function. You should have said that first you would cube, and then you would multiply by 2, and then you would add 1. Let's look at the inverse function. The inverse function, first we would subtract 1, and then we would divide by 2, and then we would take the cube root. Let's think about what do we notice about these two functions. They're inverse operations, and they are in the inverse order. So when you see f with a superscript -1, read that f inverse. Also, we should think about the relationship of the input and output. So if a relation or function f pairs one element a of its domain with an element b of its range. That would be like a coordinate AB. Then the inverse function has the reverse ordered pair. So b is the input, a would be the output, because the inverse function undoes everything that's been done to the x in the function. So the domain of f is equal to the range of inverse f, and also the range of f is going to be equal to the domain of the inverse of f. So let's imagine that we have some function f, and say that we substitute 4. So 4 is going to be my x element, or we could call it our domain element. And let's say this is what the function does, so it multiplies by 2 and then it adds 3. We'd end up getting out 11. So that is my y value, or we can think of it as our range value. Now if we think about substituting 11, so our output value, that should get us back to our original domain value of 4. So we substitute in 11, and we subtract 3 and divide by 2, and that results in 4. So here we have an element 11 gives 4, and that's our x and y pair. So notice the x and y elements are switched from each other in the function and the inverse function. And if we were to make a composite function, where we perform the first function and then the second function, of course we would get back our original value. So if I think about applying a function and then its inverse to a value, I should get back my original value. And the order doesn't really matter, so if I apply an inverse function to some value and then the function to that value, I should get back my original value. So take a look at these lists below and see what you notice about them. So you should have said that you thought the lists were inverses of each other, and the evidence for that is that the elements of the domain of the first list happen to be the elements of the range of the second list, and also the elements of the range, or the y values in list 1, appear to be the domain elements. Now that we've seen what the table would look like, let's take a look at this function g, and I want you to say what the inverse function of g would have as its elements for x and y. And then over here on the right we also have a graph of the elements of g, and this may just be a relation, and those are plotted. So I want us to also plot the elements of inverse g, and then we'll take a look at what we have. So you should have come up with this table and then the dots in red on the graph to the right. Can you see the symmetry between the points I plotted for g and the points that we plotted for inverse g? If we draw a diagonal line y equals x, it may be easier to see the symmetry now. Notice that the inverse function graph is going to look like a reflection across the line y equals x. So think of these points reflecting across that diagonal y equals x line, and that's because we are switching the x and y coordinates essentially. Here are a few examples of some common functions and their inverse functions. So take a second, look at that. The green line in each of those cases is the line y equals x, and the function is pictured with its inverse function.